In the South Pacific during 1943, an unauthorized modified aircraft was rewriting the rules of aerial warfare. Military manuals dictated that medium bombers should attack from a safe altitude. However, Major Paul Pappy Gunn transformed his B-25 Mitchell into a war machine. It flew just 50 feet above the ocean surface, unleashing devastating bursts from .850 caliber machine guns. Then it dropped bombs that skipped across the water like stones thrown by a child. The deafening roar of the Wright R-2600 engines mixed with the deadly staccato of the weapons. This created a symphony of destruction the Japanese had never experienced. This was not conventional warfare. Instead, it was lethal improvisation, born from necessity and the genius of a man who refused to accept limitations. What began as unauthorized modifications in Australian hangars would become a tactical revolution. It would forever change the nature of anti-ship attacks in the Pacific theater. This proved that sometimes the most effective innovation arises not from engineering offices, but from the desperate minds of combatants facing the brutal reality of war. Paul Irvin Gunn arrived in the Philippines in 1927 as a civilian pilot for Philippine Airlines. However, when the Japanese attacked Pearl Harbor, this 43-year-old Texan had already become a local legend. Flying dangerous commercial routes between remote islands, Gunn developed a unique intimacy with aircraft, an intimacy few military pilots possessed. When the war broke out, he immediately enlisted in the Army. But first, he evacuated his Filipino family in a desperate aerial odyssey that would separate him from them for years. His wife Polly and their 4 children managed to escape on the last flights before the Japanese invasion. This experience left Gunn with a thirst for revenge, which would shape his future innovations. Unlike academy-trained pilots, Gunn possessed practical knowledge of aeronautical mechanics. He acquired this knowledge in improvised airfields and precarious workshops. This combination of civilian experience, personal motivation, and technical expertise created the perfect environment to revolutionize aerial warfare. When assigned to the 3rd Attack Group in Australia, Gunn found a frustrated air force. It was equipped with obsolete tactics and faced an enemy dominating the seas. The ineffectiveness of conventional bombing against Japanese ships soon became a brutal reality. High-altitude attacks proved fruitless against mobile targets in the ocean. Pilots returned with disheartening reports of bombs exploding harmlessly meters away from enemy hulls. Meanwhile, Japanese anti-aircraft artillery responded with deadly barrages. The B-25 Mitchell, designed as a medium bomber, carried only 2 50 caliber machine guns in its nose. This was insufficient armament to suppress naval defenses before the main attack. Gunn observed these failures with growing frustration, his analytical mind processing every detail of the mission reports. American military doctrine emphasized precision through altitude. However, Gunn questioned this fundamental approach. His experiences as a civilian pilot had taught him that proximity meant control, and control meant effectiveness. While others accepted the limitations imposed by manuals, Gunn began to visualize radical modifications. These modifications would transform the Mitchell from a hesitant bomber into a lethal predator. The seed of revolution was planted in the mind of a man who refused to accept failure as inevitable. In improvised hangars at Charters Towers Air Base, Australia, Gunn began his experimental modifications. He worked with limited resources and questionable authorization, collaborating with Australian mechanics, who were equally frustrated with the ineffectiveness of conventional attacks. He started by installing additional .50 caliber machine guns in the B-25's nose. The first modification involved removing the bombardier's station and installing 4 fixed cannons pointing forward. This instantly doubled the aircraft's frontal firepower. Initial tests revealed devastating potential, but also significant technical problems. The weapon's recoil affected flight stability, while the additional weight altered the aircraft's center of gravity. Gunn and his team worked through the nights, welding reinforced supports and recalibrating control systems. Each modification underwent testing in risky flights over the Coral Sea. Gunn personally piloted prototypes that could easily disintegrate under the weapon's stress. Senior officers watched with growing skepticism. However, the firing test results were undeniable. The modified Mitchell could unleash 3,200 projectiles per minute in a lethal concentration. The real turning point occurred when Gunn developed the 8 machine gun configuration, creating what became known as the Strafer package. 4. 50 caliber cannons were mounted in the nose, 2 on each side of the fuselage, and 2 additional ones in ventral positions. This configuration transformed the B-25 into a mobile fire platform. It was capable of saturating targets with unprecedented projectile density. The total weight of the ammunition reached 2,400 pounds, requiring extensive structural modifications to maintain the aircraft's integrity. Gunn discovered that the secret lay in synchronization. All 8 weapons fired simultaneously. This created a cone of destruction 100 yards wide at 500 yards distance. Tests revealed that this concentration of fire could penetrate light naval armor and devastate ship superstructures in seconds. More importantly, the sheer volume of fire was sufficient to completely suppress enemy anti-aircraft artillery. This allowed for previously suicidal low-altitude approaches. The transformation was complete. The medium bomber had become a specialized ship hunter. In parallel with armament modifications, Gunn developed the revolutionary tactic of skip bombing. He adapted ricochet techniques he had observed in children's games. The physics were elegantly simple. Bombs dropped from low altitude and high speed skipped across the water's surface like thrown stones. They maintained enough momentum to penetrate naval hulls below the waterline. This technique required extreme precision, an altitude of 50 to 100 feet, a speed of 250 miles per hour, and a specific approach angle to ensure effective ricochet. Gunn spent weeks practicing over Australian reefs, using inert bombs to perfect the technique. He discovered that 500-pound bombs were ideal. They were heavy enough to maintain trajectory after ricochet, yet light enough to allow multiple units per aircraft. Timing was critical. Bombs had to be released exactly 300 yards from the target for a perfect ricochet. Combined with the firepower of the 8 machine guns, this tactic created a devastating attack sequence. First, saturation with projectiles to suppress defenses, then bombs skipping directly into enemy hulls. The first operational test of the complete configuration occurred during an attack against a Japanese convoy near Rabaul in March of 1943. 6 B-25s modified by Gunn approached at 50 feet of altitude. Their 8 machine guns created a curtain of fire that immediately silenced the merchant ship's anti-aircraft artillery. Japanese pilots, accustomed to high-altitude attacks, were paralyzed by the sight of American bombers. These bombers flew almost at mast level, unleashing continuous bursts as they approached. The sound was deafening. 48 machine guns firing simultaneously created a roar that could be heard miles away. When the bombs were released, they skipped perfectly on the calm ocean surface. They penetrated the hulls of 3 cargo ships in explosions that sent columns of water and debris hundreds of feet high. In less than 5 minutes, 12,000 tons of Japanese supplies were sinking to the bottom of the Pacific. Pilots returned with euphoric reports. They finally possessed an effective weapon against enemy navigation. The initial reaction from the American military command was mixed. It combined admiration for the results with concern about unauthorized modifications. Conservative generals questioned the safety of low-altitude flights and the reliability of field-modified aircraft. Some officers argued that Gunn was violating engineering protocols and putting crews at unnecessary risk. However, the numbers were irrefutable. Conventional high-altitude attacks had a hit rate of less than 5% against moving ships. In contrast, Gunn's modified Mitchells achieved 85% accuracy. Colonel Paul Wurtsmith, commander of the 5th Air Force, became an enthusiastic supporter of Gunn's innovations, authorizing larger-scale modifications. Operational pressure was intense. Japanese forces controlled critical maritime routes, and conventional methods proved inadequate. Gradually, skepticism gave way to pragmatic acceptance. If it worked, it should be implemented. Gunn then received authorization to establish an official modification workshop, transforming clandestine experiments into a recognized military program. The large-scale production of Gunn's modifications faced significant logistical challenges in the Pacific theater. Additional 50 caliber machine guns needed to be transported across an ocean controlled by Japanese submarines. Meanwhile, specialized ammunition required dedicated supply lines. Gunn established workshops in Port Moresby and Dobodura, training local mechanics in the modification techniques he had developed. Each conversion took 72 hours of intensive work. This involved precision welding, recalibration of control systems, and extensive flight tests. Demand quickly outstripped production capacity. Pilots from unmodified squadrons urgently requested conversions after witnessing the effectiveness of the Gunn ships. Maintenance problems also emerged. The additional stress from the 8 machine guns caused accelerated structural fatigue, requiring more frequent inspections and component replacement. Despite these difficulties, production reached a rate of 8 modified aircraft per week. This created a growing force of specialized ship hunters that began to significantly impact Japanese operations in the region. The Japanese responded to the new American tactics with desperate countermeasures. They intensified anti-aircraft artillery on merchant ships and developed specific defensive formations against low-altitude attacks. Japanese naval commanders, initially confused by the aggressiveness of the new American attacks, quickly recognized the deadly threat posed by the modified Mitchells. Japanese intelligence reports described the demon bombers that appeared out of nowhere. These aircraft flew so low that their propellers almost touched the waves. Anti-aircraft gunners received specific training to engage low-altitude targets. However, they found that the volume of fire from the American Strafers made an effective response almost impossible. Some Japanese units attempted to use Zero fighters as close escort for convoys. However, the B-25's speed and maneuverability at low altitude neutralized this advantage. More significantly, the Japanese began avoiding maritime routes close to American air bases. This forced costly detours that extended travel times and increased vulnerability to submarine attacks. Psychological warfare was equally important. Japanese merchant ship crews developed a palpable fear of Strafer attacks. During the Bougainville campaign, Gunn's modified Mitchells demonstrated devastating capability against Japanese port facilities. Coordinated attacks against the port of Rabaul in October of 1943 involved 24 Strafers flying in low formation. Their 192 machine guns created a storm of projectiles that destroyed docks, fuel depots, and anchored ships. The precision of skip bombing allowed selective attacks against specific targets. This was achieved without excessive collateral damage to infrastructure that could be useful after Allied capture. Pilots reported a surreal sensation of flying through explosions of their own bombs, with fragments and ocean spray hitting their aircraft. The psychological intensity of these attacks was extreme. Flying at 50 feet of altitude through concentrated anti-aircraft fire required nerves of steel and absolute confidence in the modified aircraft. Many pilots developed specific superstitions about their gun ships, refusing to fly different aircraft. The survival rate was surprisingly high due to the speed and low altitude of the attacks, which made tracking by enemy artillery difficult. Operational success completely validated Gunn's innovations. Refining Strafer tactics, the development of specialized formations maximized collective firepower. Gunn created the modified diamond formation, where 4 B-25s attacked simultaneously from slightly different angles. This created an inescapable cone of destruction. Each aircraft had a designated firing sector, ensuring complete target coverage without friendly fire risk. Timing was synchronized through simple visual signals. The formation leader would rock his wings to initiate the attack, and all aircraft would open fire simultaneously. This coordination created a devastating psychological effect. Japanese targets faced 32 machine guns firing in unison, followed by a rain of skipping bombs. Radio communication was minimized to avoid Japanese interception, forcing pilots to develop sophisticated gestural language. Training for these formations was intensive, requiring daily practice flights over Australian waters. Novice pilots spent weeks perfecting coordination before participating in operational missions. The result was lethal precision that transformed individual attacks into systematic annihilation campaigns. The technical aspects of the modifications revealed Gunn's improvised genius in solving complex problems with limited resources. The ammunition feeding system was completely redesigned to support 8 simultaneous machine guns. This required customized ammunition belts and precise synchronization mechanisms. Gunn discovered that weapon vibrations could cause feeding failures. He developed special shock absorbers made from recycled rubber from damaged aircraft tires. Machine gun cooling became a critical problem during prolonged bursts. To address this, Gunn installed additional air ducts that directed cold airflow directly to the barrels. The weight of the ammunition required careful redistribution to maintain the center of gravity. This led to the removal of non-essential equipment and the relocation of fuel tanks. Each modification was meticulously documented in technical diaries that Gunn kept, creating a field manual. This manual would later be used to standardize conversions. Stress tests revealed that the B-25's structure could withstand modifications without compromising safety, thus validating Gunn's experimental approach. The strategic repercussions of Gunn's new approaches transcended immediate tactical gains. They profoundly shaped American air doctrine in the Pacific. The 5th Air Force Command began planning operations specifically around the Strafer's capabilities. This involved coordinating naval attacks with ground offensives for maximum effect. American military intelligence noted a significant decline in Japanese maritime traffic on routes near Allied air bases. This indicated that the fear of Strafer attacks was altering enemy logistical patterns. The Japanese were forced to use night convoys and longer routes, which increased operational costs and reduced supply efficiency. More importantly, the success of the modified Mitchells inspired the development of other specialized anti-ship attack aircraft. These included modified versions of the A-20 Havoc and B-26 Marauder. The concept of field modification became officially accepted, leading to the creation of specialized engineering units for operational adaptations. The revolution initiated by Gunn in Australian hangars was transforming the fundamental nature of aerial warfare in the Pacific. The personal accounts of pilots who flew the Gunn ships reveal the human intensity behind the operational statistics. Lieutenant Robert "Buzz" Wagner described the first Strafer mission as flying through hell with steel guardian angels. The extreme proximity to targets created a visceral connection between the pilot and the destruction caused. This was unlike high-altitude bombings where the results were abstract. Pilots could see the faces of Japanese sailors moments before the attack, humanizing the conflict in a disturbing way. Many developed specific pre-flight rituals, personally checking each machine gun and counting ammunition as a way to control anxiety. The camaraderie among Strafer crews was intense, united by the shared experience of flying missions others considered suicidal. Letters home rarely mentioned attack details. However, family members noted a change in tone, growing confidence mixed with emotional overload. Some pilots reported recurring dreams of the sound of the 8 machine guns, a hypnotic rhythm that became the soundtrack of their war experiences. A comparative effectiveness analysis demonstrates the overwhelming superiority of Gunn's tactics over conventional methods. Official 5th Air Force statistics show that Strafer attacks achieved a ship destruction rate of 73%, compared to 12% for conventional high-altitude bombings. The cost per ton of Japanese shipping destroyed fell from $45,000 to $8,000 when using modified Mitchells. This represented a revolutionary operational efficiency. The average attack time reduced from 45 minutes to 8 minutes, minimizing exposure to enemy fighters and anti-aircraft artillery. More significantly, the crew survival rate increased to 94%, due to the speed and surprise of low-altitude attacks. Ammunition consumption per ship destroyed drastically decreased. Where conventional bombings required an average of 23 bombs per sunken target, Strafers achieved similar results with 4 to 6 skipping bombs. These statistics convinced even the most conservative skeptics in military command, leading to the official adoption of Gunn's modifications as an operational standard. The numbers did not lie. The tactical revolution had become a strategic necessity. The development of Japanese countermeasures forced the continuous evolution of Strafer tactics, creating a technological arms race in the Pacific theater. Japanese engineers developed low-altitude anti-aircraft artillery, specifically designed to engage Strafer attacks, including 25mm automatic cannons with rapid tracking. Gunn responded by modifying attack profiles, using terrain and weather conditions to mask approaches. Morning fogs became tactical allies, allowing strafers to emerge from obscurity at distances impossible to effectively engage. The Japanese attempted to use decoy ships with concentrated anti-aircraft artillery. However, American pilots quickly learned to identify these traps through suspicious navigation patterns. The introduction of Japanese radar on larger ships required the development of low-altitude approach tactics. These tactics exploited detection limitations near the ocean surface. Each Japanese innovation was quickly analyzed and neutralized through tactical modifications, demonstrating the superior flexibility of American forces. The war of constant adaptation favored the side with greater capacity for improvisation and technical resources. The logistical aspects of Strafer operations reveal a hidden complexity behind operational successes. The consumption of .50 caliber ammunition increased by 400% in units equipped with modified Mitchells. This required a complete reorganization of supply lines in the Pacific. Each Strafer consumed 2,400 projectiles per mission, compared to 600 for conventional bombers. This created a demand that tested American production capacity. Specialized maintenance became a critical bottleneck. Mechanics needed specific training for modified weapon systems, and spare parts were often improvised locally. Gunn established a technical training program that produced modification specialists at advanced bases. This reduced dependence on centralized workshops. Additional fuel was necessary due to the extra weight of weapons and ammunition, requiring auxiliary tanks that reduced operational range. Mission planning became a complex exercise in balancing firepower, range, and survival capability. Despite these complications, operational effectiveness justified the increased logistical costs. Gunn's mental journey, as he pushed his creations, reveals a profound metamorphosis from a civilian pilot to a true military revolutionary. His personal correspondence shows a man initially motivated by personal revenge. He gradually developed a broader strategic vision. The forced separation from his Filipino family created a relentless determination to accelerate American victory. However, it also created an emotional burden that influenced his technical decisions. Gunn frequently worked 18 hours a day on modifications, driven by an urgency others did not fully comprehend. Relationships with senior officers were tense. His civilian experience and advanced age created a unique dynamic within a traditional military hierarchy. Younger pilots initially questioned the authority of a man who had never attended a military academy. However, operational results quickly established universal respect. Gunn's personal diaries show the evolution of his tactical thinking. He started with simple modifications and progressed to revolutionary concepts that would redefine aerial warfare. His personal transformation mirrored the technological transformation he was creating. The transformations introduced by Gunn had a profound and lasting effect on the morale of American troops. They forged a sense of technological superiority that radiated beyond the Strafer units. Pilots from other specialties requested transfers to squadrons equipped with modified Mitchells. Attracted by their reputation for effectiveness and superior survival rate, stories of successful attacks quickly circulated through air bases, creating a legend around the gun ships. This inspired general confidence in American capabilities. Mechanics felt a special pride in working with modified aircraft, developing technical expertise that distinguished them from colleagues in conventional units. Soldiers' correspondence home often mentioned new special bombers that were beating up the Japanese, also raising family morale. The military command recognized the propaganda value of Gunn's innovations. They used operational successes in press releases that reinforced the narrative of American technological superiority. The psychological effect extended to the enemy. Intelligence reports indicated that Japanese crews developed a specific fear of Strafer attacks. A detailed technical analysis of the modifications reveals the surprising sophistication of Gunn's improvised solutions. The aiming system for 8 machine guns required precise calibration. This ensured fire convergence at an optimal distance of 400 yards. Gunn developed an alignment method using floating targets in calm waters, adjusting each weapon individually until a concentrated impact pattern was achieved. The harmonic vibration of the 8 machine guns firing simultaneously created a frequency that could cause structural fatigue. This forced the installation of customized shock absorbers at critical points of the fuselage. The weight distribution of the ammunition required complex calculations of the center of gravity. Gunn created loading tables that specified exactly how many projectiles to load in each position to maintain flight stability. The electrical system was modified to support the additional demand of the machine gun motors. This included an auxiliary generator installed in the bomb bay. Each modification was rigorously tested through test flights that Gunn personally conducted, taking risks others considered unnecessary. The resulting technical documentation became the basis for standardized modifications later implemented in American factories. The persistent influence of Gunn's contributions fundamentally altered how American armed forces viewed technological adaptation in times of conflict. The concept of field modification, previously discouraged by rigid regulations, became an accepted practice. This accelerated the implementation of operational improvements. A combat engineering program was officially established, creating formal channels for innovations originated by operational personnel. American universities began studying Gunn's methods as an example of creative thinking under pressure, incorporating case studies into engineering curricula. The aeronautical industry adopted modular modification principles that allowed rapid adaptations for specific mission requirements. More significantly, American military culture developed greater openness to unconventional ideas. This recognized that innovation often arises from unexpected sources. Post-war, Gunn returned to the Philippines to reunite with his family. He continued consulting on the development of military aircraft until his death in 1957. His modified Mitchells were retired, but the principles he established continued to influence the design of attack aircraft for decades. The revolution that began in Australian hangars had become a permanent part of American military doctrine. During the last months of 1943, when American air superiority in the Pacific became undeniable, Gunn's Strafers participated in operations that sealed the fate of Japanese shipping in the region. Coordinated attacks against the retreating merchant fleet from Rabaul resulted in the destruction of over 200,000 tons of enemy shipping in just 6 weeks. Pilots reported apocalyptic scenes of entire convoys in flames, with cargo ships sinking in formation, while Japanese survivors struggled in the oily waters of the Pacific. The lethal precision of skip bombing had become so refined that pilots could select specific targets within naval formations. They spared hospital ships marked with red crosses while systematically destroying military vessels. This selectivity demonstrated not only technical mastery, but also the moral discipline that distinguished American forces. Japanese commanders facing unsustainable losses began completely abandoning daytime maritime routes. This confined naval movement to risky night operations that drastically reduced logistical efficiency. The war at sea had become a unilateral hunt, with Gunn's predators dominating waters that once belonged to the empire of the rising sun. The complete transformation of anti-ship aerial warfare in the Pacific was consummated when the last Japanese convoy attempted a desperate run through the Bismarck Strait in December of 1943. 24 of Gunn's Strafers intercepted the formation at dawn. Their silhouettes emerged from the morning nebula like mechanical specters of destruction. In 15 minutes of intense combat, 8 cargo ships and 3 escort destroyers were sent to the bottom of the ocean. They carried with them the last vestiges of Japanese capacity to sustain isolated garrisons. Pilots returned with ammunition, exhausted, and fuel at its limit. However, they also returned with the certainty that they had participated in the decisive moment of the naval campaign. The waters of the Pacific, once dominated by the Imperial Japanese Navy, now belonged to American aerial hunters. Paul Pappy Gunn had fulfilled his personal promise of revenge. More importantly, He had rewritten the fundamental rules of modern warfare. His tactical revolution, born from the pain of family separation and forged in Texan determination, proved that the most powerful innovation arises when desperate necessity meets relentless genius.